Hello. Yeah, in this video, I want to introduce a framework for regression model building via variable clustering and likelihood ratio test. So as shown here in the graph, step one is fit the basic model, and I'll explain what basic model is. Step two is group predictors. So you put predictors in different groups. And then step three, identify significant groups is to find out which group of predictors significantly improve model fit. And you do this by using the likelihood ratio test. Step four is sequential model building. So using those significant predictor groups, you can add them to the basic model, and you can evaluate the AIC value, and then you pick the smallest AIC value and add it to the basic model. Then you repeat step 1, 2, 3, and 4. And until you cannot improve model fit by adding more groups of predictors, then you arrive at the final model. So step 1, fit the basic model. First, fit the basic model with the dependent variable regressed on basic control variables. Basic control variables here, they include demographic variables as well as control variables that are scientifically important. So here is where we use scientific knowledge to select the variables. So if a variable is really important scientifically or biologically or clinically, they will be included in the model regardless of their statistical significance. So this is the step where the theory will come into play in model building. Step 2 is group the predictors. Group the predictors into different groups based on scientific theory and the relations among these variables. For example, you have a large data set with a large number of predictors, but you can group predictors that are all like genetic factors. You can group predictors that all relate to physical activity. You can group predictors all relate to diet. You can group predictors all relate to environment. So you can kind of using scientific knowledge to group the variable together. Like even for all genetic data, you may be able to group genes based on certain pathways, right? So this is where again you can use scientific theory or published literature as a guidance for grouping variables together. Sometimes if you don't have scientific theory or literature to guide you, then data-driven approach, like some variable clustering technique, can be used to apply to identify latent groups of predictors. Sometimes they work really well. The groups are very clear, but sometimes the groups are not very interpretable. But either way, you will get groups of predictors instead of working on predictor one at a time. Step 3, identify significant groups. So what you do is add one group of predictors at a time to the basic model, and drop all the groups of predictors that do not yield a significant likelihood ratio test result. So what this is saying is, if after controlling for the basic, the control variable in the basic model, adding another group of predictor does not really improve model fit. So we don't really need to include those predictors. So after step 3, then we'll have several significant predictor group. So among the significant groups, you can select the group which decrease the AIC value the most, and then add it to the basic model to form a larger model. So here is you can find among the significant groups, you find the best model. And then you can fit a larger model using the basic model plus that the best groups of predictors to fit a larger model, and then drop all the insignificant predictors based on the likelihood ratio test. Then you replace the basic model by this new larger model, and then you go back to step 3 and repeat the process again until adding more groups do not lead to a significant likelihood ratio test result. And at that time, you arrived at the final model. So then you can fit a final model with the basic control variables and significant predictors in the significant groups added to the basic model. Again, then you drop all the insignificant predictors, then you get the final model. Then evaluate the goodness fit of the model, and then draw inferences from the final model. Okay. So as you can see, this approach is feasible when you really have maximum likelihood estimation, so that you can compute the likelihood and you can compute the AIC values. For example, you can really do this in the generalized linear models, especially like logistic regression models. Okay. I have not really researched the accuracy of this model building process, which is kind of a combination of theory and data analytic techniques. It's supposed to be an approach when you have a large number of predictors as compared to number of observations. So you really have to make choices of the predictors. So this is at least a approach. But of course, there's other analytic approaches for variable selection. For example, you can fit a GLM with lasso, right? Like automatically drop variables that's not selected by the lasso criteria. But at least the current approach, I think, is appealing because it lets researchers really think along the line of the scientific theory, as well as using the maximum likelihood estimation, which has a lot of nice properties, and also follow the parsimonious model principle in scientific modeling. Okay. And next, I'll do a demonstration using an example in logistic regression. Okay, now we're in our studio. So this is a hierarchical way to build a logistic regression model by grouping predictors based on theory and or variable clustering and using the likelihood ratio test. First, I want to import a data set. So import data set from SPSS. Let me browse. This is the data set I wanted, HSB2. Okay, then import. And you can see the SHB2 object is there. Let me go back to the syntax. So first I just reassign this data set into DF. And then I fit basic model with demographics, with female. Let me just show you the data a little bit. So you get ID, female, race, SES, school type, program, read, write, math, science, social studies, and honors composition. The honors composition is computed from the writing score. So we're not going to use the right variable as the predictor. But we'll fit first the group as the basic demographics, so gender, race, and SES, model 1. The next one, we try the group of school level variables, school type, and the program to the basic model. We can use the update command, so model 2, we put update model 1, and we use a new formula, get a model 2. Then we can apply the likelihood ratio test to see if the school level variables are significant. So this tells us, yeah, they do improve the model fit. But then we can try another group of individual level variables. They're reading, math, science, and social studies scores. So we do a model 3, update model 1, and using a new formula, and we do likelihood ratio test, and this is also very significant. So after that, so it seems that those two groups of predictors significantly improve model fit, by adding them to the basic model. So which one should we select first? So here is so we print out the summary of the model, and we can get the AIC value. So for the model 3, the AIC value is 170.05. For model 2, the AIC value is 208.93. So smaller is better, so we should pick model 3. So we should put the group of individual variables first. Let's do that. And then we want to really look at the significant predictors. We drop the science and social studies. Then we refit model 3. Then do another test. Now all the variables are significant. So the female is not significant at 0.05 level, but we don't care because it's a basic demographic variable. And then we can put the group of school level variable to the latest model. So update model 4 by adding the school level variables. We do a likelihood ratio test, and now you see the p-value is 0.99. So this is really saying after controlling for the individual level predictors, there's no benefit in improving model fit by adding the school level variables. So our final model is model 4. So we can draw inferences from this model. Okay, and I hope this I have made a point by using this approach and this example. And happy building statistical models. Thank you.